So in this lab, you're going to be making something called Oobleck. Now, Oobleck's a lot of fun, but the main thing is you're going to be building some lab skills and developing conceptual knowledge of lab or science terms. The skills you're going to be building include learning to measure properly with an analog device like a graduated cylinder. The conceptual knowledge you're going to be developing is furthering or deepening your understanding of the difference between an observation and an inference. And then you're going to go a little bit beyond that, in that you're going to be writing what's called a conclusion in a claim and justification form. Now, what I mean by claim and justification is you're going to be claiming something, and then you're going to write a clear and convincing justification, an explanation for why you think you've made that claim or why you think that claim is correct. One of the things you're going to be using in this lab is a digital balance. Now, these digital balances are kept in a box. When you take them out, you need to make sure you plug them up and give them a few minutes to warm up. So just taking them out of the box and plugging them up may not be enough. You may need a few more minutes for it to warm up so that you get a good reading on the device. The power cable for this digital balance is supposed to be kept wound up very neatly. So please make sure when you put it back that you wind it up in this fashion. A mistake that students sometimes make is they fail to remove this cover plate. Make sure you do that. Then press the on button here, and you may not have a balance that looks exactly like this, but most of the procedures work just about this way. You have to wait a minute for it to give you a 0.00 grams reading on the balance screen. Now, initially, some of these balances may start to creep up. That is to say, it might say 0.001, then 0.002. And if you watch it, it keeps going up and up and up. And what you need to do is just allow it some time for the circuitry to warm up. And just keep pressing the 0 button to zero it out again. Or you can press the off button and then the on button again. Those things will sometimes get it to settle down, but sometimes it may take a few minutes for it to settle down. And now we're ready to start measuring out the materials we need for our Oobleck. On the back side of every lab table are a series of drawers with your lab equipment. Now you can look through here and find the things that you need. One of the things you're going to need when you measure something on the balance is a plastic cup or a weigh boat like this, for example. There are also plastic cups in some of these lab drawers, and you can use a plastic cup to measure your material in, or you can get some weigh paper. So over on the middle table, I keep this little container here that has paper in there that you can weigh your material with. So I'm going to be using weigh paper for this, and you can use, like I said, a plastic cup if you choose. But when you put the weigh paper on the balance, you'll notice that there's a weight here. You want to weigh the chemical that we put on the weigh paper and not the paper itself. So what I'm going to do is to tear, T-A-R-E, tear the balance, which just means to press the 0 button, and now the balance shows a 0 with the paper on there. So when I put the chemical on the balance, it will show me only the weight of the material I'm putting on the balance and not the weight of the paper. Now we need 25.00 grams of white powder for this lab. And the white powder will be found in this plastic container here. And we're simply going to open it up. Now when you're weighing out chemicals, it's very important that you be very careful about handling the chemicals, because it's really easy for some of these things to go flying all over the lab table, and we don't want to leave the lab table contaminated. In fact, when you leave the lab table, you need to make sure you wipe it down very carefully before you leave. So we're going to just gently sprinkle this material on here until we get to that 25 gram mark. Okay, now going just a little bit over here. It's important that you know never to put chemicals back in the original container. What that does is it has the potential for contaminating the original containers. And trust me, we've had some problems with labs before because the chemicals have been contaminated. So rather than do that, what I'm going to do is I'm going to take some of this chemical and remove it from the balance. I'm going to put it on a paper towel, because in this case, the excess chemical can go in the trash can. So very gently, I'm going to be removing what I need, or what I don't need, rather. And we're pretty much there. Now, if you're not dead on 25, it's okay to be a few hundredths of a gram below or above. So here I've got 25.02, and that's perfectly okay. Just want to make sure I have a good measurement. Now, before you forget, always write down every measurement. Anything you do in the lab, any observation of any material. So you should be writing down observations in your lab notebook of this material. What does it look like? How does it appear? Is it granular or powdery, or everything about it? What's its color? And then you also need to make sure you write down very carefully what the measurement is and label what that measurement is. This is not just 25.01. This is 25.01 grams, and it's not just 25.01 grams. It's 25.01 grams of white powder. You need to make sure you give not only the measurement and the units of measurement. The measurement is 25.02. The unit of measurement is grams, but also what it's measuring, in this case a white powder. So now we're going to measure out our 18 milliliters of the green liquid we need. Now it's important that you note that some of these graduated cylinders have two kinds of markings on them. Some of them go up from 0 at the bottom up to 50, and some have 50 at the top, or 0 at the top, and go down to 50 at the bottom, or go down to 40. You can't really see the 50 at the bottom. The ones that are going down are designed to show how much liquid is being taken out of the graduated cylinder. The ones that are going up are the ones that show how much is being put into the graduated cylinder. And for this lab, we're going to be measuring how much is put into the graduated cylinder. All right, so we're ready to put our liquid in here and measure out 18 milliliters. Now what I'm doing here is, if you look carefully, you can see that there are some bubbles, or were some bubbles, at the very top of that liquid. So I want to thump that and get the bubbles out so that I can see exactly where that liquid is located. We're getting close to the 18 milliliter mark, and so rather than continue to pour from this really large jar into the graduated cylinder, it might be better now if I were to use something that will allow me to put smaller amounts in there. Remember, we don't want to put any of the liquid back in the original container because it can contaminate the original container. So what I've done is I've removed a small graduated cylinder from the lab storage drawers, and I'm going to make sure it's very clean before I start. If you look carefully, you can see some material over here. So I'm going to clean that out before I get started. Regardless of whether it appears that your glassware or any measuring device or devices you have for moving chemicals from one place to another, whether it looks clean or not, don't assume that it is. There are a lot of chemicals and a lot of contamination that can be on these things that you can't see. But I've cleaned this one out now, and I'm ready to pour a little bit in here. Okay, so now I'm ready to I'll find a what's called a barrel pipette, a plastic pipette, and you'll find those again in the lab drawers. There's all kinds of things in these lab drawers. Okay, you want to rinse this out and make sure it's clean before you start. And here's the little pipette. I'm going to take a little bit of this liquid and put it up in the pipette. I'm ready to put it into the graduated cylinder and try to reach that 18 milliliter mark. Earlier we said we're going to learn to measure properly with a graduated cylinder. Now it's important to know what these markings are on the side of the graduated cylinder. So you can see it says 40 down here and 30 up here. We want to be around here where we're filling up from 10 up to 20. Okay, and so if we're very, very careful and count carefully, we can see that we're going from 10 up to, well, if this is 10, that's 20. This must be 15. And there's markings in between here of 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 is where 20 is. So each of these markings must represent then a half a milliliter. You need to make sure you're measuring or filling your graduated cylinder to the 18 milliliter mark. Now you need to know where the meniscus is on this too. This liquid, when you put liquid in a glass container like this, the liquid tends to make a kind of a cup or bowl shape, and that's called the meniscus. You want to measure these liquids at the bottom of the meniscus. You need to look very carefully and find the bottom of the meniscus and make sure when you put your liquid in there that you're measuring the amount you want at the bottom of that meniscus. It might be difficult to see the exact measurement, to see that meniscus. And for that we have this black and white card. You can find that in your lab drawer. And if you kind of move that up and down, it'll create a kind of line at the bottom of the meniscus. If you look very carefully now, you can see a kind of a black line at the bottom of the meniscus. It's easier to read that and find out exactly when you have 18 milliliters, or as close as you possibly can. If you're ever so slightly below that, then you're going to say it's not 18 but 17.9 or 17.8. If it's ever so slightly above that, that's 18.1 or 18.2. Now, it's important to write down exacting measurements, and when we say 17.9 or 18.1, that's an estimate. And we're always going to estimate one more digit of measurement beyond the measurements that are on this device. So if you have your meniscus, the bottom of the meniscus, the bottom of that bowl or cup shape, directly on 18.0, then you're going to say 18.0. That 0.0 is that estimated digit. We always want to estimate one more digit than the smallest markings on the device. So I've got my 18 milliliters of liquid measured out now. We're ready to go on to the next step. So every person in the lab needs to have one of these Ziploc bags. And we're going to start by opening it up. And we're going to pour our green liquid into the Ziploc bag. And then we're going to very carefully, and a little bit at a time, put the white powder in here, and then what's called knead it, which means just kind of squeeze it and mish it all together so that you get a nice even consistency of the solids and liquids. Now it's very important that you very, very gently and carefully handle that white powder because it's really easy to spill that. I'm just going to put just a little bit in here. And I'm going to mix that a little bit together very gently so I don't spill any of my white powder on the table. Okay, I'm going to seal it up. And now I want to start to knead it and get it all nice and consistent. And you're going to keep putting this white powder in here and mixing it together until you've got a very even consistency. Now what you're aiming for here is the consistency of what I like to call syrup in winter. Okay, I've got that all kind of mixed together. Now I'm ready to put some more in there. It's important that you keep the white powder off of this zippered part of the Ziploc bag because it'll cause leaks if it's in there. So that's why I was careful to pour it over across the edge of that Ziploc bag. And I'm going to knead this, to squeeze it and mix it all together and get all the liquid and solid all mashed up together and have an even consistency. So right now you can look and see this is a very liquid sort of, it's really pouring very easily. We don't want that. We want it to pour very slowly. So I need to keep putting some more of this white powder in the bag. Now I just kind of went ahead and dumped it in there. That's not really the best choice, but I'm trying to do this for you rather quickly. And I'll keep kneading that. Now when you mix your material together, you're going to find that you're either going to get a little bit too dry or a little too liquid. And that always happens, and that's kind of the nature of this lab. You can see I've got some of it dripping, but some of it isn't dripping at all. And so what I want is a little more liquid in there until I get the consistency I want. I basically want all of my material to run like this, really slowly, in this slow liquid sort of moving material. So I'm going to take this beaker, which I put the liquid into, and the dropper, and I'm going to put just a little bit of liquid in there. And then I'll close it up and knead some more until I get, and I keep working it like this until I get the consistency I want. Now you may put yours together and find that yours is a little too runny, in which case you're going to put just a little more powder in there. You just keep working it back and forth until you get that kind of consistency. Now sometimes students get a little bit over anxious here and they start squeezing this bag a little too much, and they actually end up pushing a hole in the bag, especially in the corners or the edges. Don't do that. Just be gentle with this. Squeeze it firmly but not too hard so you don't punch a hole in it. So this is the consistency you're looking for. When you turn it over and let it runs slowly, like syrup or molasses in wintertime. Now don't forget that when you're done, you need to make sure you clean up any powder that's spilled on the lab table or any powder that's been accidentally spilled onto the balance or anything else is not clean, needs to be cleaned up. Wipe everything down with a paper towel. Now the graduated cylinder needs to be rinsed out carefully and then fill with distilled water. So I filled this graduated cylinder with distilled water, and I want to cover the top of it with something called parafilm. And you cut out little squares. It comes in a large roll, and you cut out the little square of it and peel this paper backing off of it. And this is the side that's sterile. And we're going to just wrap it over the top here of the graduated cylinder and kind of pull it down on the edges, and it'll seal up nice and tight. So there's an airtight seal there. And if we seal these graduated cylinders like this and store them this way, then when we're using them, they will pour without a lot of extra drops left over. We're going to get much better measurement as a result. Now make sure you clean up the lab table before you're done, and then you're going to take your Oobleck home and finish the lab at home there. Now what you're going to do at home is you're going to make a judgment. This is the claim and justification. You're going to claim whether you think this is a liquid or a solid. Now if you feel this, it feels kind of solid when you squeeze it. When you turn it upside down, it flows like a liquid. And so you're going to make a judgment. Is it a liquid or a solid or something else? If you don't remember the definitions of liquids and solids, go look them up. That's a good thing to use the internet for. But when you make a claim like that, you have to justify it. So you have to have something on which you've based your claim. If you think it's a liquid, you have to justify your claim based on the definition of what a liquid or a solid is. If you think it's a solid, you have to justify the claim based on what you know a liquid or solid to be. And so that's going to be the post-lab part of this that you finish at home. So once everything's put together, you can start cleaning up. Any of the excess liquid you have can go down the sink, and make sure you clean out your containers like this. Rinse them out very carefully. Make sure they're nice and clean. If they need to be washed with soap and water, you can do that. It's also important that you clean out these barrel pipettes, so you can rinse water up in there from this beaker like this and rinse it out carefully. So underneath your lab table is where your cleaning materials are located. And you can see that there's a bucket down there, and there's some soap in there, and here's a sponge. And every table should have some soap and a sponge. If it's not there, let me know. But you can use that to help clean up. Also at your lab table, you've got this towel here. And this towel is used for cleanup, so you can wipe down the lab table if it's damp or wet with this towel, but do not dry your hands with this. You never know whether this towel is going to be contaminated or not, and you don't want to leave chemicals on your hands. Make sure you wash your hands with soap and water in the sink, and that you dry your hands with paper towels. Never leave the lab unless you've cleaned up first, and that means cleaning yourself up as well. So any glassware or plasticware that's been cleaned can be left on a paper towel like this to dry.